have this rocket that, for me, which is amazing of this rocket, is I believe is made by the same guys of the Go Fast, but a few years later, because the guys from the Go Fast rocket, they found this company called Up Aerospace, which is received funding from NASA. And they create this other rocket. And this time to this rocket, they put, this
all the meters and all the data there.
The data here that take account the airspeed, the altitude, but also the outside air temperature. And when you start looking this, at the beginning is high, or not high, I mean it's positive, but then start to, more high you get, and the temperatures go down. And this is in Fahrenheit. But when this rocket reach the limit, about 100 kilometers, 120 kilometers, the Fahrenheit, it reach almost the 0 Kelvin degrees, which is minus 462, 65 Fahrenheit. So up there is almost perfect cooling state.
Meaning everything stops.
So exactly. So you have this superfluid state at the beginning of this gradient. So if you extrapolate going more up, I believe it's crystallized, forming like a cupola.
One thing I never understood is how is it that, of course, they say that they can take the temperature of the sun, and they can tell you the temperatures of the layers of the sun, all this stuff. They say it's an atomic explosion and whatnot. But then when you get closer to it, it starts getting super cold. So how do you take the temperature from it? It gets cold as you go closer to it. So is it hot? Huh?
I don't know.
It's weird.
It's weird. I don't know. So the thing is, you have this state of superfluid. The temperatures is going really, really down until reach maybe the 0 degrees, which nobody, reach never ever that temperature, but it's almost, 0 Kelvin there. And then you have, this is how is this gas produced. For me, this is like the pillars of the dome, if you want to see in the symbolic way, because every eruption of this is like concentrating all this gas that doesn't allow us to maybe go more up. So the fact is that...
So is what you're saying here, Edu, is that this is constantly renewing. It's almost like the Earth itself is creating this.
Yes, this barrier. Barrier. And so in fact, in terms of chemical properties, this gas is 20,000 times more, produce more greenhouse than the CO2. 20,000 times more than the CO2 for every kilogram of this gas. And every time that the volcano makes this eruption, you can imagine how many kilograms it put up in the atmosphere. So because the people say, okay, but if it's 6 times heavier than the air, how reach up there? Well, here is one of the answer. But remember, the CO2 is 1.6 more heavier than the air, and still is up there, because when they reach that temperature, it freeze and keep there.
So you're saying, okay, things that are denser than the air can go up, because when they get heated and they get dispersed in a certain way, their density goes down, they go up, even if they might not in a stable condition have less density than air.
Yeah, because but in terms of measurement, they measure the atmosphere, and it's there. It's there with other gases. It's not. This is official statistics and properties of our atmosphere.
So they can say that there's a layer of this up there. They say that officially, that there's a layer of the exofluoride.
Yes,
all the way, and that they can measure it.
Yeah, a really big layer. And in fact, they say, but cyan is the gas with a long useful life, like 3,000 years. It's contributed to the global warming is considered high. And this is official. This is official. So when you go to the properties of this gas, you have these properties. You know, because it's 6 times heavier than the air.
Right.
When you put this kind of aluminum boat, it's floating. But when you can, you know.
So you could drink it if you wanted. You could drink this thing.
Yeah, and the voice
Gives
is
you
going
a
to put
a very low voice.
Low.
Yeah.
Yeah, in the low.
Oh yeah, you're showing this before. People have shown that years ago, right? People are looking at this.
Yes.
And, there's a whole show where they all take it. They're like speaking in a low voice.
Yeah,
Like Darth
you can
Vader.
see here how it's dripping the gas and shoot down in a circular pattern, and also the electricity. For example, you put there,
Cuts it, right?
it's an off.
Oh
Yeah,
wow.
when you get so
So
it's like
not
a super
conductive.
insulator. Is that correct?
yeah, super insulator, exactly. So when you, for example, the sound.
Wow. Sounds like an airplane.